With nephritic, the primary disorder is dealing with neutrophil. Keep that in mind. Because I've asked you to focus on that H, let's take a look at hypertension. Now understand, whenever there is issues of renal failure or issues with the kidney in general, you are going to retain that sodium, therefore contributing to that hypertension. Now, when I say there is massive protein loss with nephrotic syndrome, understand that even nephritic, you are going to lose protein, but it will not be as much as 3.5 grams of protein lost per day. Greater than 3.5 grams of protein loss per day automatically puts you in the category of nephrotic, and its edema and nephrotic will be significant. You are still going to lose protein with nephritic syndrome, but not as greatly. So therefore here, the type of edema will be periorbital type of puffiness, and once again, usually due to that salt retention and resulting in increased hydrostatic pressure. Edema can be more generalized. However, remember, the type of edema is not going to be as profound as what you find with nephrotic. Next, along with hypertension and mild edema, periorbital puffiness, the fact that you are producing very little urine, oligo. Last time we looked at the term prefix oligo was when we were dealing with hydramnios, little amniotic fluid. This is little urine production, oliguria. We have approximately, and you must know the definition, of approximately 400 milliliters of urine being produced per day. You pay attention to units. Due to, once again, decreased GFR from a inflamed glomeruli, hence the neutrophils coming in. Here's your second H, the hematuria. Now, with the hematuria, what does that mean? What type of RBC have we discussed earlier that would then lead you to think that the damage actually took place with the glomerulus? And that, in fact, would be a dysmorphic RBC. What does that mean? As an RBC passes through the glomerulus, there's every possibility that there might be a part of that biconcave RBC which might not be a outpouching. That's a dysmorphic RBC, irregular membrane, due to inflamed glomeruli from immune complex deposition. Let me give you a prototype for nephritic syndrome, and actually let me give you two of them. One was called IgA nephropathy, aka Berger, and the other one will be post-streptococcal glomerulonephritis. And as the RBC is trying to make it through, it might then become dysmorphic. Now, your laboratory findings that are relevant for nephritic include the fact that you would find neutrophils in the sediment, particularly in the immune complex type. So that's more involved with inflammatory processes. The RBC casts are key findings. Now, let me walk you through this real quick with nephritic. Number one, H, hypertension. Under hematuria, we have RBC casts, and we have dysmorphic RBCs. Do you see as to how that fits in perfectly? You just need to make sure that you organize your patterns and thoughts accordingly. The protein urea will be less than 3.5 grams per day. That's important that you pay attention to. Yes, greater than 150 milligrams, but definitely less than 3.5 grams per day, because anything beyond this, what category does that put you in? Very good. Nephrotic. Under nephritic, your BUN creatinine ratio, well, tubular function is intact in acute glomerulonephritis. And that's very important for you to understand. Why? Give me a condition in which your tubules are also damaged. Good. It's called acute tubular necrosis, isn't it? So when you have acute tubular necrosis, the physiology behind that is the fact that you cannot reabsorb any urea. Where's urea in this ratio? B, blood, U, urea, N, nitrogen. Ah, there's urea. So in acute tubular necrosis, you can expect that ratio to be decreased. However, in acute glomerulonephritis, you can still expect your azotemia to be relatively elevated. Isn't that interesting?